Thanks everyone for joining the session today. Today we are going to go a detail on SD-WAN evolution. My name is Somarajan. I'm working in the network industry for more than 25 plus years in various networking technologies as well as automation product, both in enterprise and service provider network, plus part of my work in Cisco. Before we discussing more about SD-WAN, first we want to talk about the evolution of the WAN network itself. Initially, I started working on the WAN network in late 90s, where mostly the WAN network was built using frame relay and HEM later on. Mostly the topology built that time was hub and spoke between branch and central office and between regional and central office full mesh to establish, and the traffic pattern itself is pretty much the same, where all the branches talk to the central office for any accessing any application, and the customer from internet connected to the central office for anything like a website for accessing the application or anything from the central office. So then comes the next revision of the technology, where late 90s, Cisco come up with MPLS. The first version of the MPLS was built on top of the HEM. That's called IP plus HEM. So it's evolved was the first application from MPLS, which is the MPLS VPN, used for branch and branch connectivity. The MPLS VPN can build a topology of hub and spoke, full mesh, and partial mesh. That is pretty much was in line with what was deployed everywhere, and then most of the traditional frame relay HEM are replaced with MPLS VPN topologies, and the traffic pattern was pretty much the same, going to the branches to the central office and between the central offices, and the internet was just a browsing, used only for browsing. So the majority of the traffic was east-west traffic, and then very minimum traffic to the internet for browsing purpose. The next evolution of evolution came with the mid-2000, where initially the public cloud came into existence, as well as a lot of applications start evolving on the internet as SaaS application. That changed the traffic pattern of traditional traffic pattern of majority of the traffic being in the east-west direction, change it to more and more traffic is north-south traffic. So that's where I think the SD-WAN started evolving in late 2000 time frame. So if you look at the summarizing that, there are three major drivers. The number one is the change of the traffic pattern. So more and more traffic is towards the branch directly to the internet, and also every packet, traditionally every packet which is going to the internet steer towards the data center, and from there to the central office, and from there it taken to the internet, which so it overhead, additional overhead. And the third thing is internet application, SaaS and public cloud required quality of service for the service. That it required more handling, application performance handling for the transporting the packets. So these three things are the major reason why the SD-WAN evolved in late 2000s. So this slide, we are going to cover the full evolution of the SD-WAN, and starting from the WAN optimization, and today where we are with the secure access edge. So the first, as we spoke early in the previous slide, where we mentioned that the SD-WAN evolution started in a late 2010-12 time frame. Prior to that, there is a stage where the packet, priority packet was treated differently using WAN optimization technique to make sure the avoided traffic congestion for some of the without impacting the application. And then also there is a phase where we have both MPLS VPN as well as the traditional internet-based WAN existed as in the hybrid mode because of the stability in the traditional internet-based VPN and internet-based technology evolution. So that's where the early stage of coexisted MPLS VPN as well as the internet-based VPN. And there are early, in Cisco there was something called I1 which started on that stage where we have automatically determined which path to take it using some policy-based routing, early stage of that SD-WAN journey. Then this comes to the full evolved SD-WAN where we have centralized control, both control plane and data plane separated, and also we have an fully automated, orchestrated and automation solution came. That's where the 2015 time from the SD-WAN started. Let's talk about the next evolution of the SD-WAN technology. Late 2015, the traffic is increased in the north-south direction more than before because of the cloud deployment acceleration as well as the SaaS application acceleration. These two trends even to accelerate the cloud deployment scenarios in two ways. One, the cloud SD-WAN itself deploying in cloud infrastructure as well as all the application in the cloud policy can be enabled to manage cloud native application performance and traffic pattern. And later in 2020 timeframe, when the COVID hit the world, what happened is there also increased the number of users as well as the application increased, and the traffic pattern become more and more random in nature in terms of like anywhere to anywhere. So that also accelerated this cloud-based SD-WAN. And then the later part of it actually now where we are today is that because of this new traffic pattern, it is very important that both the security as well as the network traffic need to be shared together in a way that in an integrated policy fashion so that the user have the desired of network traffic flow, application traffic flow, along with the required security. That's where we are today. And then most of the vendor is working on the new, the secure access edge, it's called SASE, in their portfolio. Either they are in the middle of the building or they are in the beginning of the building that and putting a roadmap for that. So this is the overall journey. Hope you understood this. Let's talk about the WAN optimization. As we saw in the evolution of SD-WAN, WAN optimization was the earliest phase in SD-WAN evolution, where the WAN traffic was treated separately and compressed, and also reduced the latency using different techniques. It's called WAN optimization techniques, and these solution was typically deployed the traffic over the WAN. Specifically, it was more prioritization was done for the application which is delay or sensitive, like voice and real-time voice and data. And also the low priority traffic is treated differently to make sure that they got the required quality for the application, end-to-end application. Let's talk about the hybrid WAN. So this is where I think after the WAN optimization, we have entered a phase where we have, this is I1 is an example, early phase of Cisco's I1 is an example where we have the two link from the branch to the central office. There are or the other connection as well. There are two links. One the link which carry the mission critical applications, which is over an MPLS link, and all other regular traffic which will go through a regular internet connection. So this give a way to optimize the cost as well as what is it has become more help to move towards the SD-WAN technology, because it is underneath it use a policy based based on the policy, the application will be routed through the MPLS link or to the internet link, right? So this is actually helping just bringing, migrating to the SD-WAN technology later on with separating the control plane and data plane. So this was the evolution towards the SD-WAN fully separated data plane controller plane driven SD-WAN. Let's deep dive into SD-WAN. So the key change in the SD-WAN is that both data plane and control planes are separated and run in a different part of the different network architecture. So if you see, I have the two pictures here. One is a traditional MPLS network where we can see the end-to-end topology the below, and the top one is actually the SD-WAN topology, where we have the edge as well as we can see the centralized cloud, where we have the control plane of SD-WAN running. So these are the two separate topologies. If you look at deep dive into each of them, the key difference is that the traditional MPLS network, where both the control plane and data plane is reside in the router and branch router. So it's actually relatively a smart, more bigger devices with more intelligent. So it's also it's required to bring up to the branch and install it in it's more manual process. But versus like looking at the SD-WAN, which have the control plane sitting on the cloud, and the data plane, the edge devices are sitting on the branch, where we have the minimum intelligent, but mostly the data forwarding is a primary function. So that way, there are two benefits out of it actually. One benefit is that the cost of the edge device goes down, and also it can be a hardware or a software solution. And other benefits are like there are topology wise, there is in the SD-WAN topology, you can see that there are multiple links going from the branch. One goes towards the internet directly and the other one towards the data center. The key benefits of that, the traffic towards the internet and towards the SaaS service as well as the cloud is from the branch is steered efficiently than the previous branch to all the traffic need to go to the central location before going to the internet. So these are some of the key benefits of the SD-WAN when we move to the topology on the top. So hope you got a good understanding of the SD-WAN differences as well as the different how the topologies are different. Let's dive into the cloud-native SD-WAN. Cloud-native SD-WAN is a natural evolution of the standard SD-WAN due to the explosion of cloud adoption from 2010 onwards, and also a lot of SaaS applications are evolved over the period of last 15 years on the cloud. These two aspects, accelerated the SD-WAN, cloud-native SD-WAN. So there are two aspects of the cloud-native SD-WAN. One aspect is that all the application running in the cloud need to be managed and differentiated based on their SLA requirement. So it's a policy is extended for cloud applications, as well as the other aspect is that SD-WAN can be deployed in the cloud infrastructure, so that the flexibility of the cloud and the scalability of the cloud can be used for the SD-WAN deployment itself, and also managing the different type of cloud topologies of hybrid, multi-cloud, single cloud, public cloud, all those different aspects of the topologies as well as the application in the cloud. Hope this you understood the cloud-native SD-WAN and the different aspect of it. So let's walk into this one particular flavor of the cloud-native SD-WAN called CN-WAN. In this topology, what we are showing is how the CN1, the SD-WAN, standard SD-WAN extended as CN1 to integrate and manage the application like Kubernetes and also any cloud native application which is running in the cloud, to make sure the services can be, in this specific case, the Kubernetes services, how it can be extended to managed by the SDN topologies and SDN benefit. So in this case, I think we can see that there is this can be also managed by different cloud topologies, hybrid cloud, public cloud, as well as multi-cloud topologies. Let's talk about SASE. SASE is called Secure Access Service Search. It is a text evolution of the cloud native SD-WAN. So where today the most difficult problem is how we, with the evolution of the remote users as well as application running in premises and cloud, and also SaaS application, integrating the data flow along with the security is one of the key challenge. So that's where I think the secure access services come into play. So everybody today is actually following, so it's called zero trust security. No trust, trust, everything is verified before authorized and authenticate and continuously verified, to ensure that the users and also the data and also devices are access the network as well as the data on the network securely. So that's goal of the secure access service search. This is extending the benefit of the SD-WAN to the security, so that security as well as the network connectivity work together seamlessly to make sure that this making sure all the traffics are, as well as the access are controlled securely and managed securely across the end-to-end. Let's look into the key difference between SD-WAN versus SASE, right? So the first aspect is actually how the network itself is done, so deployed. So it's actually in the SD-WAN, it's create an overlay network using physical or physical software or cloud-based application, and available through managed or hybrid deployment, right? In case of SASE, it's always going to be cloud-based and globally distributed through as a service deployment. And the second aspect is that's how the security is integrated. So in the today's standard SD-WAN, we require a third party to help for the end-to-end security point of view. But for the SASE deployment, the security is built in, so it's integrated, so it's part of the solution itself. So in the current topology, branch offices to network and follow the organization configure policy to determine how to route the traffic. But in the SASE case, connect the endpoint to the edge and traffic sent through globally distributed POPs. So, and there is no backhauling of the data to the data center. The other aspect is the built-in remote access aspect of it, actually. So there is no third party involved in case of SASE, where it is built in. And the last one is actually the skill required. The standard SD-WAN, only networking skill for deploying is the networking skill is required. But for the SASE, it's an integrated, both security and networking skill is required for SASE application. So let's conclude. Let's go through the summary, right? What we learned so far. SD-WAN have evolved from WAN optimization to hybrid WAN to SD-WAN and finally to SASE, right? So with the evolution of the SD-WAN evolved CN-WAN. CN-WAN is where I think we have the cloud native WAN which extended for cloud native applications and services, as well as cloud-based deployment. And finally, the Secure Access Service Edge is emerging architecture that combine SD-WAN and the security in a single platform. So these advancements have brought significant benefits to both business, including improved application performance, reduced WAN cost, and enhanced security and integrated security. And also it supports the evolving zero trust security, which is a new security model for the cloud and for premises. Thanks for attending the session today. Hope this helped you to enhance your knowledge on evolution of the SD-WAN. If you need, please subscribe the channel and you to get such more free training on this platform. Thank you.